Hello guys, in today's slide we are going to discuss about relationship between area of a cone and sector. uh, First period objective of this slide. At the end of this lesson you should be able to derive the relationship between area of a cone and sector, and two, you should be able to know the formula that connects base radius of a cone and radius of a sector, and how to apply Pythagoras theorem to find the perpendicular height of a cone. Now, before we even move further, what is a cone? Uh, from here now, if you look at it very well from this place, it is given that a cone is formed when you fold a sector, then you have what we call a cone. Let's look at this. This is a sector, this is a cone. If you use this A to join this B to join this A, like this, what you are going to have is a cone, which is this. You understand? If you use this A to join this B, what you are going to have is a cone, which means that when we fold a sector, we have a cone in that manner. So then the arc length of a cone is given as the arc length of a sector is given as theta over 360 2 pi r, while the circumference of every circular object is given as 2 pi r, which means that the circumference of this base of this cone here is 2 pi r, while the circumference, that is the total distance of this circular object here too, is 2 pi r. Now, what is the relationship between them? Now, from the previous explanation, you can now deduce that the arc length of the arc length of a sector is given as theta over 360 2 pi r, which is this. And when you fold cone like that, is what is going to give you the base radius. It's going to give you the base circumference of that cone, which is the same thing as 2 pi r. Remember that from our previous knowledge in plane shape, for every circular object, the circumference is given as 2 pi r. And if you fold your cone, you are going to have something like this as the base. You understand? And the length of arc for that sector too, the length of the sector is given as theta over 360 2 pi r, and that is on that one. Then another thing that you still need to know is, if we now have that one now as the formula that is connecting them, then you should be able to know what is r and what is the big R and what is the small r. That big R is for the radius of the sector, while that small r is for the radius of the circular base of the cone after it has been folded. Now, if you use this 2 pi to divide this 2 pi, what you'll be left with will be theta over 360 times r equals to r. This r here is radius of the cone, that is when it is folded, and this r is the radius of the sector, and that is the first relationship between them. Then the second thing is, after the cone has been folded, you have something like this. Where we have this place to be h height, this place to be the radius of the cone, while this place is the slant height. We call it slant height of the cone. Then, using Pythagoras theorem, provided this place is a right angle, we have the square on the slant height, which is the hypotenuse side, which is L square, equals to the sum of square in other two sides, which is h square plus what? R square, like that. And That's how we arrive at this one. Then, and that is that concerning that one. Also, from this same cone here, if we are looking for any side, assuming that this place is angle A, then we can use any relation from the SOHCAHTOA to relate R and L. Remember that in SOHCAHTOA we have TOA to be opposite over what? Adjacent. Opposite over adjacent. From this one now, the opposite to this angle A that is here is R, which is R over the adjacent should be H. That's the reason we have tan A to be R over H. We have tan A to be R over H. Likewise, if you use so, which is sine of the A equals to the opposite over hypotenuse, we have it to be R over L from the same trigonometric ratio. And that is that concerning that one. Remember that the curved surface area of a cone is given as pi RL, where R is the radius of the base of the cone and L is the slant height of the cone. Total surface area of the cone, total surface area will now equals to curved surface area, which is the pi RL that I just mentioned now, and the area of the base, which is pi r square. Then the volume of a cone is given as 1 over 3 pi r square h, where r is the base radius and h is the perpendicular height of the cone. Then let's move to the next up. I believe at the end of the first period, you should be able to write the relationship between the cone and the sector. And secondly, you should be able to write the expression that is connecting the perpendicular height and the sector. Remember, I said it that when you fold a sector, we have a cone. When you fold a sector, you have a cone. And the arc length of a sector is given as theta over 360 times 2 pi r. I use capital letter R because it is radius of the sector. I want to use it to show the difference between 2 pi r, which is after it has been folded. If you use this one to remove this one, you have r equals to theta over 360 times r, and that is the first relation between them. The second one is after the cone has been folded, you have right angle triangle, which you can use Pythagoras theorem for, and the SOHCAHTOA. And that is the end of the first period. Without wasting much of our time, let's move to the second period. At the end of this second period, you should be able to apply all these formula to solve different problems. You should be able to apply all these relationship to solve for the height of the cone, to find the base radius of the cone, to find the angle of a sector, and to solve for radius of the base radius of the sector. Now, let's solve example 1 now. Example 1, question 1. What is the area of the curved surface of the cone generated by the sector of a circle of radius 6 cm and arc length of 22 cm? Then solution, the answer. Remember that the relationship between radius of a cone, the base radius of a cone, and radius of sector is this. Is that then from the formula of arc length, I said it is theta over 360 2 pi r over 360 2 pi r, and the arc length is given as 22. Therefore, 22 equals to theta over 360 2 pi r. Our radius of the sector is given as 6. Is here? It's given as 6. Therefore, if you substitute for the value, you have theta over 360 2 pi 6. Then making theta over 360 the subject. Making theta over 360 the subject, because that's the only thing that is not in the formula for the curved surface of a cone. Then if you make it the subject, you have it to be 22 divided by 2 pi 6. 22 divided by 2 pi 6 will give you 22 divided by 2 divided by 12 pi. That's for that. Then the curved surface area of a cone is given as pi RL. Then from the relation R equals to theta over 360 times R, then if you sub that one for the value of small r there, you have pi RL equals to pi into bracket theta over 360 times R times L. Then if you equate it, remember that our theta over 360 times R is given as 22 over 12 pi. Then if you sub for the value, then pi cancel pi, then we have 6 times 6 will give us 36 times 22 divided by 12 will give us 66 as our answer. And that is that concerning example 1. Now example 2 now. Question 2. A sector of a circle of radius 8 cm sustains an angle of 90 degrees at the center of the circle. If the sector is folded without overlap to form curved surface of a cone. Full stop. Find 1 the base radius, 2 the height, and 3 the volume of the cone. Take pi to equals to 22 over 7. Answer. Solution now. Then remember the length of an arc equals to circumference. That's the first relationship between sector and a cone. We have theta over 360 equals to what? 2 pi r here, which is the first relationship. Our theta is given as 90 degree. If you put 90 degree in place of that theta, you have 90 over 360 times 2 pi. Our radius is given as 8. Is given as a radius of 8 centimeter is given as 8. Then you put the radius to equals to 2 pi r. Then making r the subject. If you make r the subject, it means that we are going to divide both sides by 2 pi. If you divide both sides by 2 pi, this one we remove this one. You have 90 times 8 divided by 360. I mean, from this place, we have 90 times 8 divided by 360. Since you have used this 2 pi to cancel that other 2 pi. And if you press your calculator properly, you have 2 centimeter as your radius, which is the base radius of the cone. That second one, the II, the Roman numeral 2. From the cone now, we have the cone to be like this. Remember, we have something like this. If this is the height and this is the base radius, we have R to be this, we have H to be this, and we have L to be this. Using the same Pythagoras theorem, you have 8. 8 is the radius of the sector. H is the radius of the sector, but after it has been folded, you understand, it will change to the slant height. It will be the slant height. After you use this place to touch this place, then this place will turn to the slant height, therefore which is L, and it is given as what? 8. Then 8 square equals to H square plus R square from Pythagoras theorem. Our R is what? 2 centimeter, the one we calculated for. Then if you substitute the value, collect the like terms, we have our H square to be 60. Find the square root of 60, you have H to be 7.75 centimeter. And the volume of a cone is given as 1 over 3 times 2 pi r square H. Then our pi is 22 over 7. Our r is what? 2. Our H is 7.75. If you sub for the value, you have your volume to be 32.48 centimeter cube, which can be approximated to be 32.5 centimeter cube. Example 3. Question 3 now. A cone of height 12 centimeter has a base radius of 9 centimeter. Base radius of 9 centimeter. Stop. If the shape is cut and open out into a sector of a circle, what is the angle of the sector? Remember that the slant height of the cone is given as L square equals to H square plus R square. Our slant height is what? L square, which is given as the height of the cone is given as 12 and the base radius is given as 9. Then if you substitute for the value, we have our slant height to be what? We have our slant height to be 15 centimeter, which is the R if it is opened into sector. This is what I mean. If you have something like this, you understand? Then if it is now open to be this one will be R, which is the same thing as slant height when it is folded. And that is that concerning that one. Now we are looking for the circumference of the cone is the same thing as the arc length. You know, the first relationship between cone and sector, which is this. You understand? Making R the subject by dividing two sides by the 2 pi. We have R equals to theta over 360 times R. Then our R is 9, which is equal to theta over 360 times 15, which is the radius, the one we calculated. Then if you substitute for the value, you discover that your theta is 18.8. Okay, your theta equals to 216 degree. 216 degree. Example 4. Find the area of a curved surface. Find the area of the curved surface of the cone generated by the sector of a circle radius 12 centimeter and arc length 22 centimeter. Solution now. Answer. Remember that the circular base of a cone is equals to arc of the sector. Therefore, we have 2 pi r. This is what I mean by that. We have this place to be circular base. This is the radius, which is r. If you are calculating for this circumference, you have 2 pi r, which is given as the 22. Which is given as the 22. If you have a sector like this, if you fold this sector, all this length is going to turn into the circular base. That's what that statement means. Then if that is the case, if this place is 22, which means that after it has been folded, it is going to be this. That's the statement. Then we now have it with 2 pi r equals to 22, making r the subject of the formula by dividing both sides by 2 pi. You have 22 divided by 2 pi. Remember our pi is 22 over 7. Then we substitute for the value, you have our r to be 3.5, which is 7 divided by 2, which is 3.5 here. So that is that concerning that one. Then the slant height of a cone equals to the radius of the sector. You know, when it is folded, it turns to slant height. When it is opened, it is the radius of the sector, which is the same thing as 2f given to us. Now, curved surface area of a cone is given as pi rl. By substituting all those values, we have pi to be 22 over 7. Our radius was calculated to be 3.5, which is 7 over 2, and our L is 12. Then if you multiply all those values, you have 123 centimeter square as the area. Then the last example there, we have question 5, example 5. A cone is formed by bending a sector of a circle having an angle of 288 degree. First of all, find the radius of the base of the cone if the diameter of the circle is 8 centimeter. The first thing we are interested in is the radius, and we are given the diameter to be 18. Then you divide the diameter by 2 in order to get the radius. That's the first step there. Then the second step is the relationship between the cone and the circumference of the base, the arc length of the sector and circumference of the base of a cone. Now it is theta over 360 times 2 pi r, which is equals to 2 pi r. Then use 2 pi to divide 2 pi. That is, this one cancel this one. You understand? Then we have theta over 360 equals to r. Theta over 360 times r equals to r. Then substitute for the value given to you. We have our angle to be 288 over 360 times our radius of the sector is given as 9, which is equal to r. Then open all those brackets and you have your r to be 7.2 centimeter. Then solve for the assignment. Question number 1 to 5. You do it and you submit it through our normal means of submitting assignments. When we meet next lesson, we continue. If you have any question when we meet during the live class, you can ask. Thank you.